This is the third in a series of videos on circular trig. And in this one we want to draw angles in standard position just like we did in the previous video, but now we're going to do it in radians. And there's actually two different ways to do this, and it doesn't matter which way you do it. One way is to do it in radians directly, and the second way is simply to change it to degrees. And after you change it to degrees, graph that one. So the first thing you do is you want to make sure and have this memorized. Let's draw a cross here. This is 360, but it's also 2 pi. So this is pi. Half a pi is half a pi, or pi over 2. That's 1, 2, 3, 3 pi over 2. And then you can split each one of these. Half of a half is a fourth, so that's pi over 4. It's equivalent to our 45 degrees. You can split this quadrant as well. That's going to be 1, 2, 3 pi over 4. This is 1, 2, 3, 4, 5. This one's 5 pi over 4. And this one's 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. There's two others that are very important that I just want you to memorize straight. And that's pi over 3 and pi over 6. You can always use a formula to change it, but these are so common you want to have them memorized. Pi over 3 is going to be 60 degrees, and pi over 6 is 30 degrees. So the easiest one that we do is when you want to draw one, and it's one that you've kind of already memorized. So let's draw minus 3 pi over 4. You could convert that to degrees, but if I think about that, if I think about what's going on here, this is pi over 4, right? Pi over 4, but I'm going in a negative direction, so that's going to be minus 1 pi over 4, minus 2 pi over 4, minus 3 pi over 4. So the easiest way to do this, first draw your initial side, draw your 4 quadrants and dotted lines. We're going to go minus 3 pi over 4. That's minus 1, 2, 3. So it's going to be right there. So that's minus 3 pi over 4. A harder one to do would be, let's say, draw 7 pi over 5. Now, pi over 5 I actually don't have memorized. And you wouldn't have either. So the easiest way to do this actually is 2 steps. First, convert to degrees, and then draw it, and then label it with radians. Is that cheating? I don't think so. They're the same, radians to degrees, so that would be a fine way to do it. So let's work through this problem. You have 7 pi over 5. You start here. Let's convert it. The way that we're going to convert this is we're going to go degrees over 360 is equal to radians over 2 pi. You may use a different formula to convert it. That's fine. No problem. Let's put this over here. 7 pi over 5 divided by 2 pi is equal to d over 360. If you have trouble with this, let me know and I can help you, or there's another video you can watch. Multiply this by 5 over 1, 5 over 1, the 5's cancel. And I get 7 pi over 10 pi, d over 360. The pi's are going to cancel, and I get d over 360 is equal to 7 over 10. I multiply this by 360 and this by 360, and I can just do that on my calculator. That's going to be, let's do, the zeros cancel. I get 7 times 36, 42, 4, 21, 252. And you're welcome to just use your calculator for that. So let's graph 252 degrees. Now when you draw it, they don't have to be exact, but you have to get it in the right quadrant. So this is 90, this is 180, and this is 270. So it's a little bit shy of 270. So it's going to be roughly there. That's going to be your radians right here. And then I'm going to label it, even though I did it in degrees, I'm going to label it as a radian. And that's how you do it. let me show you one more example with a shortcut. Let's say you wanted to graph minus 7 pi over 6. Well, the first thing you want to notice is you're dividing by 6 here. You want to have memorized that pi over 6 is 30 degrees. So you can rewrite this minus 7 times pi over 6, which is minus 7 times 30, or negative 210 degrees. Then just graph it. There's 0, or 360. This is 90, 180, 270. So you'd think it's going to be right here, except that's if we're going positive. You know this is a negative number, so this is minus 90, minus 180. It's a little past negative 180. How much is past? Well, let's go. 210 minus 180 is 30. It's 30 past that, so it's roughly going to be there. They're going to be there. Now don't label it negative 210 because then everyone knows that you've changed it to degrees. Nothing wrong with that, but it's more impressive if you use radians. And that's how you graph angles in standard position when they're radians.